In this video, I want to give you a bit of an introduction into how AM and FM radio work. You might be familiar with the radio transmitter that's in Ultimo in Sydney, and this broadcasts a lot of radio waves which come from the ABC, the Australian Broadcasting Commission. What happens then is that this aerial here gives out radio signals and might come to a radio receiver like this one here. Now, this radio receiver is both an FM receiver and an AM receiver. So this radio can take in signals which are AM, which stands for amplitude modulation, and radio frequencies that are frequency modulated. That's FM. That's what F and M stand for, frequency modulated. The whole process of creating a radio message starts in a broadcasting studio. So here, for example, you can see people who are speaking. They could be speaking or maybe even singing. And the sound waves go from their mouths then to the microphone. So this represents here a sound wave. It's rather a smooth wave. It wouldn't actually be an example of a voice. Voice is much more up and down. This is a rather pure note, but that doesn't matter. We're just sort of illustrating what a sound wave is in any case. So we've got the sound wave. As I say, it goes into the microphone. Now, when it's in the microphone, what happens is the microphone converts it to what we call an alternating current. Now, an alternating current is one in which the electrons are moving backwards and forwards, and you can see that here. Now, the way in which that happens is rather complicated, and I won't go into it, but once we do have a current that matches up with the pattern of the sound wave, then we have the next wave, which is important. And this is called a carrier wave. Now, the carrier wave is one which is generated within the electronics of the transmitter. And hopefully you can see that the frequency of the vibrations here of these electrons is much, much higher. In fact, this band goes from 530 kilohertz to 160 kilohertz, or 1.6 megahertz, million hertz. Now, a hertz is a vibration or a cycle. So here you can see the vibrations. Okay, so each one of those is a hertz. So we've got 530,000 of those per second, perhaps down here, and the highest one then is 160. So moving on, what happens with the carrier wave and the sound wave is that the sound wave is added to the carrier wave, and you can see here that it takes on the same shape as the sound wave. So this is the carrier wave, that's the sound wave, and this is combined in the transmitter so that this is the wave which then is sent out to the aerial, the broadcast aerial. So here the aerial would be up here, and we would have this current which goes backwards and forwards here. And when it does, it generates our radio waves. So the radio waves then extend out, they keep traveling out, and eventually come to somebody like me who's got a radio like this. And here is the carrier wave along with the sound wave on it. And when it hits the aerial, so here's the aerial here, when it hits that, what happens is that these hertz, this electromagnetic radiation, has the effect of making the electrons in the metal here move backwards and forwards. Now, you couldn't have an aerial made out of wood. Why? Because the electrons in wood don't move, but certainly in metal, the electrons do move, and this is what the radio wave makes happen here. So that creates a current, an alternating current, which extends into the radio itself. Now, inside that radio, what happens is this. It passes through what is called, so here it's coming through, it's feeding through into the radio, and it comes through what's called a diode. The effect of that diode is to stop or to make the current go in one direction only. So the effect of that is to cut out the bottom half of this wave. So you can see there that this illustrates the electrons moving in one direction, and that part moving backwards, if you like, is cut out. So the electrons just go along like this. They can only flow in one direction. So we've got, in fact, what we might call a DC, or a direct current. That passes through to the speaker. So here is the speaker. This is the part here which makes the sound. So as that AC, that alternating current, passes through the speaker here, this is the sound that it generates. And so that comes to our ear, and so we hear the sound. That's AM, amplitude modulation, changing the amplitude or the size of the wave. Now, here we are having a look at FM, or frequency modulation. Now here, the carrier wave has frequencies ranging between 88 megahertz and around about 108, or perhaps a little bit more, million hertz, millions of vibrations per second. So it's a much, much higher frequency. Remember, down here, this was 1.6 megahertz compared with 88, so much higher frequency. Again, what happens is the sound wave comes to the speaker, and inside the speaker we have the sound going through. As a result of that, an AC is generated. And what happens then is that this carrier wave again is used, but what happens is a different effect occurs. The frequency of the carrier wave is changed to carry the sound. So here, for example, this part here, you can see the frequency is increased. Here it hasn't changed much at all. And down here, the frequency of the wave has decreased. Here, increased, much the same, decreased. So that has the effect here on the electrons of moving them either faster, making them vibrate faster, or slower. So that's a modulation of the frequency, a change of the frequency. Again, that goes to an aerial, which is broadcast these waves here, which have this variation in the frequency. Then again, it gets to the aerial. When it gets to the aerial, again, an alternating current is generated inside the aerial and goes inside the radio. What happens is something slightly different. What the radio does now is it works out just how much faster how much the increase in the frequency was here, and if the frequency is higher, it creates a wave like this, or a current like this. If the frequency is much the same, then we get a frequency around about here. And if the frequency is less than the carrier wave frequency, then we find that we get a shape like this, or an electric current shaped like that. So this is what happens then as this wave passes through the electronics for an FM receiver. So that then creates the sound wave, a current which carries the sound wave. Again, it gets to the speaker, and what we have is the sound wave coming out of the speaker. So that's FM. Now you might be wondering, well, what's the difference between AM and FM? Why would you have one rather than the other? So there are some advantages and disadvantages of both. So here, for example, our AM, if we have a look at AM, or rather, yes, this is one of the disadvantages of AM. And the fact is that AM signals, as they travel through the air, can pick up distortions. They pick up other radio signals. Now, this is classed as electrical noise. And what the electrical noise does is it changes the amplitude. So it actually changes the message. This video here, I'll just click here to start, and I want you to listen to this. So what's happening there is that the electrical current, which is running through here, it generates radio signals. Now, those radio signals are then picked up by the aerial, and in fact, we can hear that the sound. So this is what happens with AM. Why? Because the signals, the radio signals, which are actually generated in this wire here, because we've got an alternating current going through there, those signals are picked up and then can be heard here. This is electrical noise. Now, this might be the sound or the electrical noise. It's not really sound, of course, it's radio waves. So this might be the noise which comes from the wire that I just turned on. What happens is this noise is added to the waves which come in, and as you can see, the resultant wave that comes from here is taken into the radio and passes through the diode in the usual way. And when it does, okay, we take out this bottom half as we've got here. So the bottom half there goes, and what we hear is a sound like this. So this is the distortion, this is the electrical noise that we hear. So that's interference. So this is with AM. Why? Because the noise changes the amplitude of the wave. In fact, with FM, we don't get so much interference. We do get a little bit. Just to show you that, I'll start this video. So that the sound that you hear there is simply the switch that I'm turning off and on. You're not hearing any interference coming from the radio waves which come from this cord here. Another difference between FM and AM is their ability to travel through objects. Now, it depends upon what the object is made out of, but in general, AM travels through objects a lot more easily than FM. So here's our FM, frequency modulated. So generally speaking, our FM, as it passes through objects, some of the energy is, more of the energy is absorbed. We might, inside a building, for example, get better reception from AM. But then again, it depends upon what the building is made of. Another difference between the two is how they travel. FM waves are actually used to communicate to outer space. So they can pass through what's called the ionosphere, which is a layer of the Earth's atmosphere, which reflects some waves. Now, it reflects AM waves. Now, the reason why it does this is not related to the fact that it's amplitude modulated. It's really related to the lower frequency. So here, the lower frequency, you might remember, is somewhere between 550,000 hertz and 1.6 million hertz. If we're using a frequency which is a lot higher, higher than 88 megahertz, then that can go through. It's not so much the fact that it's frequency modulated, it's actually more a result of the frequency. But anyway, it's a difference between AM and FM. Let's just summarize. So what happens in the creation of our radio is, first of all, we have something which creates sound. It goes into our transmitter, and inside the transmitter, it's either amplitude modulated or frequency modulated. It then creates the radio waves. These are the radio waves traveling out through the Earth's atmosphere, gets to an aerial, and at that aerial it makes a current, which an alternating current going backwards and forwards. That's then processed, and in the case of the amplitude modulated waves, the bottom half is cut out. The sound then goes to the speaker and comes out as sound waves. So that's a story of FM, frequency modulated, and AM, amplitude modulated radio waves.